Section 4.3 Right triangle trigonometry. Six trigonometric functions. Here is a triangle, right triangle. So included angle is theta and this angle is 90 degrees, so it's a right triangle. This side is opposite to the angle. This side is adjacent to the angle, and this is the hypotenuse of the triangle. So we can write six trigonometric functions. Sine theta equals to opposite over hypotenuse. Cosine theta is, we can write as adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cosecant theta is hypotenuse over opposite. So it looks like cosecant theta is the reciprocal of sine theta. Secant theta is hypotenuse over the adjacent. So it looks like this is the reciprocal of cosine theta. Cotangent theta is adjacent over opposite, and it looks like this is the reciprocal of tangent theta. As an example one, so we have a triangle whose opposite side is 12 and its hypotenuse is 15. Adjacent side is missing. Then we have to find the exact values of six trigonometric functions. So first thing we do is complete this triangle. We find the missing side. So this like B 12 and C is 15, and we have to find A. So we apply the Pythagorean theorem, A squared plus B squared equals to C squared. So A squared we have to find, so B is 12, so become 12 squared, and C is 15, so it becomes 15 squared. So now we bring down A squared. 12 squared is 144, 15 squared is 225. We move the 144 to the right, so it becomes A squared equals to 225 minus 144. And 225 minus 144 is 81. So A squared is 81, so A would be what? Square root of 81, which is 9. So the adjacent is A is 9. Now we complete this triangle and redraw. So now we have a completed triangle. Opposite is 12, adjacent is 9, and hypotenuse is 15. So sine theta is opposite over hypotenuse. So we can write opposite is 12, hypotenuse is 15, so we can 12 or 15. We can simplify, divide by 3, top and bottom, and get a 4/5. So sine theta is 4/5. Okay, now next is cosecant theta, hypotenuse or opposite, and hypotenuse is 15 and opposite is 12. So we become 15 over 12, we can reduce it to 5/4. Next is cosine theta, which is adjacent over hypotenuse, and adjacent is 9 and hypotenuse 15, and we reduce to 3/5. Secant theta is hypotenuse over adjacent, and hypotenuse is 15, adjacent is 9, so it reduces to 5/3. Tangent theta is opposite over adjacent, and opposite is 12, adjacent is 9, so 12 over 9 can reduce to 4/3. Cotangent theta is adjacent over the opposite, and adjacent is 9, and opposite is 12, so be 9/4, which come reduce it to 3/4. Example 2. So it says sketch a right triangle corresponding to trigonometric function of the acute angle theta, and then find the exact values of other 5 trigonometric functions of theta. So this is given to us. Cosine theta is 15 over 17. So by definition, cosine theta is adjacent over hypotenuse. So adjacent is 15 and hypotenuse is 17. So we draw the right triangle and assign hypotenuse 17 and this and this 15. Now this is missing, so we have to find this triangle using the same formula. A squared plus B squared equal to C squared. Now A is 15, it's 15, and C is 17. So we become 15 square plus B square equal to 17 square. Now 15 square is 225, B square is B square, 17 square is 289. Move the 225 to the right side, you get B square equal to 289 minus 225, which is 64. Take the square root and B is equal to 8. So now we have a complete triangle. Uh, Adjacent is 15, hypotenuse is 17, and opposite is 8. So now we can write the trig function using this triangle. Sine theta is opposite over hypotenuse, and opposite is 8, and hypotenuse 17. And then cosecant theta is the hypotenuse over opposite, and hypotenuse 17, and adjacent is, opposite is 8. So we get 17 over 8. Cosine theta was given 15 over 17. Secant theta is hypotenuse over adjacent, and hypotenuse 17, and adjacent is 15. So it's 17 over 15. Tangent theta is opposite over adjacent. So opposite is 8 and adjacent is 15. Similarly, cotangent theta is adjacent over opposite. Adjacent is 15 and opposite is opposite. So it becomes 15 over 8. Example 3, finding a missing side of a triangle when angle and one side are given. So here given is the angle is 60 degrees, and we are given hypotenuse 18, and we have to find x, which is adjacent side, and y is opposite. So let's first find the x. To find the x, we can use the ratio of x to 18. Now x over 18 is like x is like adjacent, and 18 is the hypotenuse of right triangle, and we know that adjacent over opposite is cosine theta. So theta is 60, so become cosine 60. So now we have a equation x over 18 equal to cosine 60 degrees. So we solve for x. To solve for x, we multiply both sides by 18. So we become 18 times x over 18 equal to 18 times cosine 60 degrees. 18's cancel out, you get x, gives the x is 18 times cosine 60. Now from the unit circle, cosine 60 is 1/2. So it becomes x equal to 18 over 1/2, which is 9. Okay, now next we're going to find the y, and y is the opposite side, so we can take the ratio of y to this 18, and y over 18 is sine theta. And since the angle is 60 degrees, so it becomes sine 60. So now we have equation y over 18 equal to sine 60. Now we multiply both sides by 18, so we can 18 times y over 18 equals to 18 times sine 60. 18 cancel out. You're left with y on the left side, and you have 18 times sine 60. Now from the unit circle, sine 60 is square root of 3 over 2. So we have 18 times square root of 3 over 2. Now 18 divided by 2 is what? 9. So the y is 9 times square root of 3. Fundamental trigonometric identities. First, the reciprocal identities. Well, sine theta is a reciprocal of cosine theta, so sine theta is one of cosecant theta. Cosine theta and secant theta, they are reciprocal, so the cosine theta is 1 over secant theta. Tangent theta and cotangent theta are reciprocal, so tangent theta is 1 over cotangent theta. Cosecant theta and sine theta, they are reciprocal, so cosecant theta is 1 over sine theta. Secant theta, cosine theta reciprocal, so secant theta is 1 over cosine theta. Cotangent theta and tangent theta are reciprocal, so cotangent theta is 1 over tangent theta. Now from this we can also prove that tangent theta is sine theta over cosine theta, and cotangent theta is cosine theta over sine theta. Similarly, we have Pythagorean theorem identities. Sine square theta plus cosine square theta is 1. 1 plus tangent square theta is equal to cosecant square theta. 1 plus cotangent square theta is a cosecant square theta. Trigonometric values of common angle. Here's a table. So let's see how we read this table. In the first column, we have a angle in degrees, 0 degrees, 30 degrees, 45 degrees, and so on. In the second row, we have a angles in radians. So let's see sine theta. If theta is 0, sine theta is also 0. So it's 30 degrees, so sine theta is 1/2. So 40 degrees, sine theta is square root of 2 over 2. 60 degrees, sine theta is equal to square root of 3 over 2. And if the 90 degrees becomes sine theta is 1. 180 degrees, sine theta is equal to almost 0. And 270 degrees, sine theta is -1. Cosine theta is, when it's 0, is 1. Cosine 30 degree or 5 over 6 is square root of 3 over 2. Cosine 45 is square root of 2 over 2. Cosine 60 is 1/2. And cosine 90 is 0. Cosine 180 degree is -1. Cosine 270 is 0. Tangent 0 is 0. Tangent of 30 degree is square root of 3 over 3. Tangent of 45 is 1. And tangent of 90 degrees are undefined. Tangent of 180 degrees is 0. And tangent of 270 degrees is also undefined. Here's an example 4. So we're given a triangle. The angle is given and this side is given. We have to find x and r. So we can relate this known side with the unknown side. So let's see, if I wanted to find the x, we can relate these two. So I can say x over 32. So x over 30x is like adjacent and 30 is like opposite. So adjacent over opposite is cotangent theta. So theta is 60 become cotangent 60 degrees. So now we solve this equation for x, we multiply both sides by 32. So this equation becomes 32 times x over 32 equals to 32 times cotangent 60 degrees. 32 cancel out, you get x, and you have a 32 cotangent 60 degrees. Now remember, cotangent is not in the calculator, so we can write either 32 cosine 60 over sine 60, and from the unit circle, cosine 60 and sine 6. Cosine 60 is 1/2 and sine 60 is square root of 3 over 2. And we can rewrite this 32 times 1/2 times the reciprocal of square root of 3 over 2, which is 2 over square root of 3. 2 cancel, gives you 32 times 1 over square root of 3. So we can rationalize, multiply top and bottom, square root of 3 over square root of 3, square root of 3, square root of 3 becomes 3, so we have 30 times square root of 3 over 3. Okay, so now we have to find r. So now we take the ratio of r and 32. So r over 32, r is hypotenuse, 32 is opposite, and hypotenuse is opposite cosecant theta. The theta is 60, so become cosecant 60. So now we have r over 32 is cosecant 60, and so we multiply both with 32. So we become 32 times r over 30 equals 32 times cosecant 60. 32 cancel, gives the r equal to 32 times cosecant 60. So now we rewrite cosecant 60 as 1 over sine 60, and then from the unit circle find the sine 60, and sine 60 is equal to square root of 3 over 2. So we have r equal to 32 times 1 over square root of 3 over 2. Rewrite 32, and this will count the reciprocal of this, which is 2 over square root of 32. Now 2 multiply 32 with 64 and divide by 6 square root of 3. Now we rationalize, multiply top and bottom with square root of 3. So square root of 3 square root of 3 becomes 3. So you have a square root of 64 times square root of 3 over 3. Okay. Okay, so here Example 5, a surveyor wants to determine the width W of this river. From point A, the surveyor walks upstream 150 feet and sights to point C. From this sighting, it is determined that theta is 54 degrees. We want how wide is the river. So if you look at this right triangle, so this is opposite to this angle. So we want to find the opposite side of this right triangle. So adjacent is 150. So we can take the ratio of opposite side W and the known side 150. So become W over 150. So it will be opposite over adjacent, and we remember the opposite over adjacent is tangent theta. And theta is 54 degrees, so become tangent 54 degrees. So now we solve for W, so we multiply both sides by 150. So you have 150 times W over 150 equals to 150 times tangent 54. Well, the 150 is cancelled, so you get W equal to 150 times tangent 54. Now we put this on the calculator in degree mode, so we should be able to get 206.5 feet, rounded to one decimal place. Example 6. A guy wire runs from the ground to the cell tower, to this one. The wire is attached to the cell tower 150 feet above the ground, so this is 150 feet. The angle formed between the wire and the ground, this one, is 43 degrees. How long is the guy wire? L, and then we want to know how far from the base, this is the base of the cell tower, to the ground. So we need to find this, let's say X, and this one to find L. So we can take, let's say if I want to find the X, and I will take the ratio of the X to 150. So let's say to find the length of the guy wire L, we can take the ratio of L to 150. So this becomes L over 150 equals the hypotenuse over opposite. And hypotenuse over opposite is cosecant 43 degrees. And cosecant 43 is the reciprocal of sine 43, so we 1 over sine 43. So we have a L over 150 equal to 1 over sine 43 degrees. So solve for L, multiply both sides by 150. So this becomes 150 cancels, gives L equal to 150 over sine 43. Now put this in the calculator, degree mode, and round it to one decimal place. This should come out 219.9 feet. Okay, so now we want to find the X, and X is this distance from the base of the tower to this place where this guy wire is anchored on the ground. So we take the ratio of this X and this opposite side 150. So we have X over 150 equals to adjacent over opposite, and we know adjacent over opposite cotangent theta. Theta is 43 degrees, so we come cotangent 43 degrees. Now cotangent is reciprocal of tangent, so we write 1 over tangent 43 degrees. So now to solve the equation X over 150 equals to 1 over tangent 43 degrees, we multiply both sides by 150. So it becomes 150 times X over 150 equals to 150 times 1 over tangent 43. So 150 cancel, gives the X equal to 150 times 1 is 150 of tangent 43 degrees. So 150 or tangent 43 is putting on the calculator, it becomes 160.855. Round it to one decimal place, it becomes 160.9 feet. This is the end of the right triangle trigonometry. So please make comments, and if you like the video, please subscribe to my channel. Thank you. Do your homework.